Welcome back, and let's upgrade to level 5. In the previous two levels, in level 3 with dependency injection, we managed to get under control the dependencies between our classes. On level 4 with dependency inversion, we managed to get control over the dependencies between our libraries. We have now the tooling, but we did not really have any kind of rule uh, which would determine what is the class and what is the library that has to be somehow in the center of our universe, and what are just the supporting technologies around. And then with the layered architecture, we try to answer this question. The first approach here was this classical three-tier architecture. We know it. It was quite straightforward. They defined a presentation layer, basically a UI, and there was some middleware in the middle. Quite often, the business logic was partly here, and then we had the database that was storing our data, but it was also containing some business logic in the form of some SQL queries and so on. Actually, this is quite easy to understand, but as I already pointed to this direction, we don't really have the business logic separated here. So whenever I'm changing the web server technology, or I'm changing the database technology, probably I will lose also the business logic, and then I will have to do it from scratch quite often. One step further here was the entire architecture, where we went and then we tried to split it even further. As you can see, we have again on the client layer a browser or maybe a third party who is accessing our code. And then we have this classical MVC pattern, so the model view controller pattern, and the controller and the view, I put them on the access layer. I put also there the API. So the API is for third parties, and then the view and the controller, this is for the human interaction. So basically the browser is talking to the controller. The controller is somehow the request that is coming from the browser, it is applying in the business layer, and then finally presenting the results of this operation what the user issued from the browser, and then it is sent back to the browser. Then we have the model. So the model is now becomes the center of our thinking, because we put most of the business logic here into this model. And then that's why it is written in a programming language. It is not SQL. And then this is issuing the SQL commands to go to the database and fetch the data. This is a step forward compared to the three-tier architecture, because now we have a separated model. So it means that if we want to use another web technology, web server technology, then it is much easier to do because the model stays intact. And then only in the access layer we have to change things. Unfortunately, the model still depends on the database, and that's why if we want to do some changes in the database, then most likely we will have to also touch the model. Now let's see if we can improve it even further. What we see here, this is the onion architecture. It is the very similar, very same or very similar idea can be found in the literature under different names. So, in my opinion, the hexagonal architecture or the ports and adapters is essentially the same idea. As we can see here, now the layers are not on top of each other, but we have a central component, and then the central component is surrounded by less important, more peripheral components. So if we check this, then the center of our universe is the domain. And then in this domain, we have our real business logic. This is this beautification filter. And this is just pure algorithm. So it is not, it contains some primitives that we can build a different kind of beauty filters. And then this leads to the application layer, so to the green layer, and then we have an image enhancement workflow. As you can see, the image enhancement workflow is depending on the beautification filter primitives. So basically all this domain logic what we have here in the beauty filter is basically bound together, and then we got a workflow. So it means that if the user wants to use the beautification filter, then he does not have to go and know all the intricate details, but the user can use it from a higher level and then just communicates with the workflow. And this is helping much the interaction. So basically, this is an application of the beauty filter. Now, if we are going one layer out, then we will see the peripheral layer. And then in this peripheral layer, we have some standard libraries. For example, we have a GUI library, or we have another library that provides access to camera sensor, but these are not specific to our application. So if you want to make it specific to our application, then we need another layer, and this is this adapter layer. Probably from the dependency inversion um, video, you remember the adapters. So basically we have the peripherals, and then we have the application, and the application will need some peripherals, but we don't want to make the application depend on some specific peripherals, so that for example, this workflow can be reused in other contexts, for other UI libraries for different sensors, maybe even on different platforms. And that's why instead what we do, what the application requires and then what the peripherals offers, this difference is bridged over by the adapter layers. And now you can see it is basically the very same architecture what we have for the dependency inversion, but now every component is assigned to one of the layers. So let's go from inside out. As you can see, there is the domain. The domain doesn't depend on anything. This is our core competence. This we don't want to bind with any kind of technology. Of course, it has to be bound to some programming language and then to some basic libraries, but we try to minimize the dependencies here as much as possible. And then in the next layer, in the application layer, we can depend on the domain. But actually, if we need something from outside, we want to communicate, then we will need to access some peripherals. But actually, accessing those peripherals, this is expressed in this photosensor interface. So this is a requirement interface. The image enhancement workflow is expressing its needs in the form of this interface. And now let's jump to the adapter layer. And then as we have seen in the dependency inversion discussion, then the adapter is implementing this requirement interface and then using the offered interface of the image sensor. The same applies here for the take photo panel, and then we have the composition route here. The most important thing here, the direction of the dependencies. As you can see, dependencies are always going from outside to inside. From inside, we never go outside. And that's why this is defining the reusability of your code. So the more central the code is, then the more generic it is, and then more abstract it is. So like in our domain, and then also in our application is quite reusable and generic. But as you are moving outside on the onion layers, the most outer layer, the adapters layer, this is very sensor specific, or very product specific. As you can see here, we have the composition route that describes how you can build up that specific system, and then the adaptation, the adapters of those specific systems. If we look now on the deployment view, then it also becomes much simpler. You can see here we have the image primitive library. This is our domain, and then this library doesn't depend on anything. And then we have the application layer logic that is encapsulated in the image processing lib library. And as you can see here, this is the application layer, and then as it was on the architecture layering diagram, this may depend on the domain, so on the imaging primitive libraries. And now we have, of course, the composition route. Basically, this is the product layer, and then in this product we have the composition route, and then we also have here the different adapters, and this is where we have a dependency to everywhere. This is building up the system. So this is the least reusable code. Robert C. Martin calls it the ultimate detail, this, because then this is really very specific to one specific product. And now, as you can see, the camera library is also here. The camera library, again, it is reusable on different products, but it is not a domain knowledge. It doesn't have any dependency, but it doesn't make it it doesn't qualify to be a domain knowledge because it's still just a library that we use for hardware access. The same would apply if I put here another box for the GUI library, and the GUI library would have also no dependencies, but the GUI component would depend on that. Now let's see what are the advantages, what are the disadvantages of this approach. So now we have such an architecture that can describe a full product, or even with variability a product line. Just imagine in the composition route you have some rules or some configuration, and then you can build up slightly different systems. And now we know what is the most important part. It is, of course, our domain. And now this is also expressed on the architecture, because now the domain becomes really the central point of our architecture. This is what we want to keep maybe for generations or a longer time. And then we want to separate it from the quickly changing most fashionable technology stack. Now, with this clear policy, we can put the different components into these layers. And then the dependencies are dictated by the layering. So we can influence the dependency directions with dependency injection and dependency inversion. But now we have also a clear rule set how we should do the directions of those dependencies. There are also some disadvantages. The adapter cloud poses a little bit of overhead. We already had this issue on the dependency inversion, but if you consider how much flexibility you gain on the architectural level, probably we can live with this little overhead. This describes quite well how you can build up a specific product. But actually, if you want to really scale, and then you work not within one team, but you are working with multiple teams on different sites, which are geographically separated from each other, then working on one specific product becomes quite complicated, and then maybe you want to split up your big application into smaller application, and then you need some kind of coordination. This kind of model does not really answer this question, but we will see later if we can do somehow better there. As usual, it's again an architecture analogy here. So I took from this image from the St. Peter Cathedral in Rome. As you can see here, we have the structure of the building, but you have some central structure. This is the holy altar in the middle, and then as you can see, uh, this is the center of our universe. And then we have some supporting layers around. So we have the pillars, we have the roof, we have the windows. They are all necessary for the whole thing to function, but they are not really the essence of this architecture here. But the essence is really the altar. Yeah, I already spoiled a bit what is missing here. So basically, we need here some kind of overarching strategy that scales even higher, so it can synchronize the efforts of different teams. And this is what we will see in the next video.